We are going to discussing about the digital communication laboratory. So in that digital communication laboratory, so our second experiment is the pulse width modulation. Okay, pulse width modulation. We have three different categories of the pulse modulation techniques in digital communication. That is pulse amplitude modulation, pulse width modulation, and pulse position modulation. Okay, based upon the input signal, based upon the input message signal, the width of the pulse can be varied. Okay, if we can increase the amplitude level of the message signal, the width also can be increased. If we can reduce the amplitude of the input message signal, the width also can be reduced. Okay, so to perform that experiment, we need to go for the pulse width modulation kit. Here you can see this is the pulse width modulation and demodulation circuit. So in this circuit we have PWM modulator. This is the PWM modulator. So for that PWM modulator, we have to give two different inputs. That is, first one is the AF input, that is message signal input, and second one is the clock input. You can see here the pulse width modulator internally contains the clock signal. This is the clock circuit, and this is the AF signal output, AF generator. This is the AF generator. By using these two things, two circuits, we can perform the pulse width modulation and pulse width demodulation. Okay, now let us see one by one. So now I am going to verify the input signals of the PWM kit. Here you can observe what is the output of the PAM. Here I can see this is the message signal. This is the message signal that is which we are going to use it as a input. Okay, now let us see the clock signal. So this is the clock signal. Here I am connecting the clock signal to the digital CRO. Here you can see the clock signal. So you just note down the old amplitude values and frequency values. By using this random stop value, you can just stop the signal and you can note down the frequency value and the amplitude value for the both cases, that is clock, and other one is audio frequency signal, that is message signal. Okay, this is the message signal, right? So note down the values. You have to give the connections. See here the connections. Here AF signal is given to the AF input and clock output is given to the clock input. Now let us see the output of the PWM. Here this is the output of the PWM circuit. Now let's just see here. You can observe here different types of pulses. You can note down here. See here there are different types of pulses. The width may be varied. See here the width is different. Increase, increase, decrease, 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 decrease. So there are so many types of widths came here. So based upon the input signal, the width can be changed. Let us see if I am going to change the amplitude of the message signal. Here this is a knob to increase or decrease the message signal amplitude. Let us see. I am just reducing the message signal input. See, I am just changing the amplitude levels. You can observe here the variations. If I am increasing the amplitude, the widths also can be increased. Let us see here. You can see here variations of the widths. Okay. Now let us go for the comparison. So you just need to connect the dual channel. From one is the AF signal and other one is the output of the PWM signal. Let us see what will happen. How the output can be varied. See, I am just connecting AF signal to the channel 2 for verification purpose. See here. Right. Right. You can observe here. So if the amplitude is increased, the width also can be increased. Here this is the maximum peak value. This is the maximum peak value of the message signal, maximum amplitude voltage. Here you will get the maximum width. If it is the minimum peak value, minimum value. Here you will get the less amount of width. So this is about the pulse width modulation. Okay. Now let us see. I am changing this amplitude. What will happen? See, right? I am giving 0 amplitude. Here all the widths are equal. There is no variations in the message signal. If I am increasing the amplitude values, see the variations in the widths of the signal. See, these are all the variated pulses. That is pulse width modulation. Pulse width modulation. Width of the pulse changes in accordance with the message signal. That is nothing but the pulse width modulation. Simply you have to calculate the message signal amplitude and frequency, PWM pulse, amplitude and frequency. Okay. Here I am giving two different channels. One channel is for the output of the PWM signal and other channel is for comparison purpose of the message signal. Okay. Now let us see the demodulation process. Okay. Demodulation process. So for the demodulation, you have to give the PWM output to the PWM input. Just only one connection. Here the PWM demodulator output, that is AF output. You can just connect the channel 1 to AF output. You will get the message signal. So this is the demodulated message signal frequency. Okay. So this is about the pulse width modulation. So internal message signal is there and internal clock is there. After giving to the message signal and clock to the PWM modulator, you will get the PWM output. So afterwards, you have to give the PWM signal to the PWM demodulator input and you will get the output as original message signal which is to be transmitted from the source. Okay. So this is about the pulse width modulation. By using this now, you can vary the width of the pulses. So this is about the pulse width modulation. So changing the width of the pulse by varying the amplitude of the message signal, you will get the PWM output. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.